I'm from Government Internal Audit Agency, and I'm going to be talking to you about how we've been using our Shiny apps and how we've been using Gen AI within a couple of our Shiny apps. So just a quick introduction into who we are. So we provide internal audit and counter-fraud services to most central government departments, and also agencies, arm's-length bodies, and other government departments. And one of the main goals of the data analytics team was to identify routine tasks that have been performed across the agency over and over again, and try to help make them more efficient. So just as an example, GIA generates around 1,500 audit reports every year. So if we could possibly speed that process up, that would free up a lot of time and resource for other things. So some specific challenges for the data analytics team. Firstly, we're mostly data analysts rather than software developers, so I'm not a tool expert in R Shiny. I was coming at this from more of a kind of beginner learning on the job perspective. Also, most of our work is supporting on audits, so doing data analysis to support on various different audits. So we're kind of developing the apps alongside that when we have time. There's also been turnover in the team since the project began, so some of the people who started working on the apps have now left and new people have come in, so obviously the apps, obviously they need to be really well documented, but also need to be hopefully simple for new people to pick up and understand. Also, I guess this is true for any organisation, there's a big range across the agency in terms of how comfortable people are with using technology. So we really wanted the tools to be easy to use, user-friendly, and attract lots of users rather than putting people off. And we also wanted to think about the existing standards for performing various tasks when we were designing the apps and try and build that in. So we have 3 R Shiny apps at the moment. Each one aims to support a specific stage of the audit process. So the first stage is the project scoping or planning stage, and we've got the risk engine, which uses GPT 3.5 to enable users to brainstorm and explore potential risks that an organisation might be exposed to. And I'm going to show you the risk engine in a moment. The second one is the insights engine, which has various different functionality. One of them is that GIA obviously has a big repository of previous audits, and it's really useful for auditors to be able to, if they're performing an audit on, say, workforce planning, to look at what work has been done across the agency on workforce planning. Previously, look for examples of best practice, common things that keep coming up, etc. So the Insights engine enables them to search GIA's back catalogue of previous audits using key terms, etc. It also enables people to analyze large bodies of text, so that could be audit reports, but it could also be survey responses, complaints data, any time when you've got a large amount of text data and you want to pull insights out of it without reading through everything. So the Insights engine doesn't have Gen AI, but it does have NLP approaches that enable people to analyze their text, such as sentiment analysis, basic topic modeling, and kind of pulling out common words and phrases. So that's the Insights engine. And then the last one is the writing engine, which is designed to support the report drafting stage of an audit. So this takes the rough notes that are written by auditors during their field work. Those notes, if you can imagine, if you're taking notes during a conference, you might end up with lots of duplication if similar things are mentioned across lots of different talks. You might have quite rough notes, poorly structured notes. So yeah, it takes those notes and takes certain information out of them and writes that in a kind of more cohesive, nicely written way and structures it into the format of an initial draft of an audit report. Obviously, the auditor would then need to work on it, tweak it, check it for accuracy, because AI can misunderstand, misinterpret information, but it gives them a starting point. And the users, we've got estimates that it can save about a day on a typical audit, which when you've got a large amount of audits being written every year, that's a big benefit. So I'm just going to show you I'm not going to do a live demo because that makes me nervous. So I'm just going to show you lots of screenshots of one of our apps. So I'm just going to talk you through the most simple app, which is the risk engine. All of them obviously have a landing page and about page that has lots of information about that app, when it was last updated, etc. And most of the functionality is in the risk articulation tab. This is just what it looks like when the user clicks on it. And the first thing that they need to do is put in their business objective. So this is the objective of the organization that they're auditing. And in this case, I've just put in our business objective, which is to develop user-friendly, easy to maintain our Shiny applications. Once they've got that business objective, they then can pick a risk category. So if they want to focus on, say, risks that are associated with fraud or legal risks, commercial risks, etc., then they can pick an area to focus on, or they can just leave it as any to leave it broad, which is what I did for this example. Then they click on this button that says Get Potential Causes. And when they click on that button, the app will send a custom prompt to GPT 3.5 via Azure's OpenAI service. And so, yeah, that custom prompt basically asks for 5 potential causes that might lead to that business objective not being achieved. So we want to develop user-friendly, easy to maintain our Shiny apps. What are 5 reasons why we might fail in doing that? Then once you click that button, it's quite quick. Well, I'm not doing a live demo, but it was quite quick. It comes back with a table containing 5 potential causes. So here we've got insufficient user requirement analysis. So if you don't know what your user needs are, you might not end up with a good R Shiny app. Poor user interface design, obviously that endangers your user-friendly aspect. Inadequate app testing, you might end up with lots of errors, bugs, unexpected behavior. Complex app logic, if you've got overcomplicated coding, poor documentation, then it becomes difficult to maintain and update. And then inadequate ongoing maintenance and support. So the next step is, once the user has their 5 causes, they then select one of them and they click on another button, which again sends another custom prompt to GPT to ask for that cause, what are 5 potential events that could be associated with that cause. So I chose complex application logic and got 5 potential events that might be associated with complex app logic. So we've got error-prone functionality, increased maintenance costs because it's difficult to find to make updates or revisions if the code's really complicated, difficulty in scalability, limited user adoption because the app's just too complicated, and time-consuming problem identification because it's difficult to find where the bugs are. So the it's not quite the last step, but the next step is the user then, again, picks one of those 5 events and clicks another button to, again, send another prompt to GPT asking what are 5 potential consequences of my chosen event. So here I've chosen time-consuming problem identification, and it's come back with delayed bug fixing, increased maintenance costs, reduced user satisfaction, decreased developer productivity, and increased development time. And then the last step is to pick one of these possible consequences and then click a final button to generate a risk sentence and description summary. And this aims to give the auditor the kind of risk sentence that they will use in their audit plan or in their main body of their audit. So we've firstly got a really simple risk sentence that just pulls together that cause, event, and consequence. So complex application logic may lead to time-consuming problem identification, resulting in delayed bug fixing. And then it also gives a slightly more wordy and descriptive description summary. So here we've got complex application logic resulting from factors such as overcomplicated coding, poor documentation, and lack of modularity may lead to time-consuming identification in problem identification in our Shiny apps. As a consequence, delayed bug fixing could occur, reducing the overall efficiency of the development process and potentially impacting the user-friendliness of that application. So obviously you can see that if you were using this, you might want to reword it slightly to make it, sound a bit more natural. but it gives the basis for a risk statement, and also enables people to search, brainstorm a range of risks that they might not have thought of already. This is quite beneficial at GIA because GIA does audits on a range of different things, so not just financial audits, but a broader range of potential areas. This is just what the app looks like when you've gone through the stages of picking your cause, event, and consequence. You've got them all highlighted. So what makes this better than just giving users access to a secure version of GPT? Well, firstly, we feel that it's quite a user-friendly interface, just kind of guiding the user through that risk articulation process in a step-by-step way. But also, I think one of the main benefits to this and the writing engine is that we have these predefined optimized prompts. So when you just have a chatbot, you have to figure out what you want to ask it to do. Which for some users, if they're not used to using AI tools, it can be hard to devise that prompt. And if you've got a poor prompt, then the outputs aren't going to be very good. So yeah, having those predefined optimized prompts is really beneficial. Makes it much more simple. Basically, all they have to do is think of what their business objective is, and then it's just clicking a set of buttons. And the last one is that it's designed for compliance with risk articulation standards. So having that cause, event, and consequence is really important. And sometimes people might fail to think of the consequences or fail to include one of those elements. So yeah, this encourages consistency. And obviously, as you can see, it's really quite a simple app. And also with the writing engine, we can encourage consistency by, kind of asking for certain things while GPT is writing the text, asking it to include certain things in a certain order and a certain structure, etc. So yeah, that is a quick overview of the simplest of our apps. I was just going to talk you through, as we're quite, I guess, a team of more beginner developers, some of the challenges that we found as we were going through. First of all, just deciding how to host the apps. I wasn't in the team at the time, but this was quite a time-consuming step. So we wanted each app to have 3 slots. So we've got obviously a production slot that users have access to, a development version where we can test things out, and also a staging area so that we're not just merging the development straight to production. We can, check that everything's working okay in that staging area. And also, we needed to have, most of the users are within GIA, but for a couple of the apps, we've also got some other government departments also using them. And we needed different users to be able to access different things. So for example, in the Insights engine where we've got that repository of previous audits, we only want the internal users to see that and not the external users. So yeah, the team considered a couple of different options. So apparently POSIT were very helpful in talking through the various options, and Docker containers were the one that the team eventually went with, because we already had an Azure subscription, which made it very easy, because Azure app service supports Docker containers, and it's a really easy hosting option. And because the Docker containers are lightweight and quite cost effective to run, it wasn't too much of a costly option. Obviously, as I'm sure you know, having that Docker file, defining the environment for that app, the R version, the specific libraries that you're using, the dependencies and the versions of each library, ensures that the app runs consistently across environments too. And the Docker containers, each one is like an isolated unit, which means that the app is isolated from other applications running on the same server. So lots of benefits that we found with the Docker containers. Most aspects of our apps are managed within Microsoft's Azure ecosystem, which makes things really easy. So the version control is via Azure repos. The build and deployment is automated with Azure pipelines. The Docker containers are hosted, as I said, on Azure App Service. We're using as your OpenAI service for the prompts to access GPT 3.5 for the apps that involve GPT 3.5. And Azure Active Directory is managing the silent authentication. So yeah, a lot of things happening via Azure, which keeps things very easy. We also found that the Golem R package has been really useful for us for creating consistent modularized apps. So yeah, if you're not familiar with Golem, it provides a consistent framework for developing modularized apps. And one of the, so yeah, that kind of, it means that if you're adding a new module, it's added in a kind of consistent, format. And one of the biggest benefits for us was that it includes built-in support for Docker and Azure, and creating the Docker file can be quite complicated, and Golem does it for you. So anytime you need to add a new package in, Docker will again update your, Golem will update your Docker file. So yeah, that's much more simple. Obviously, yeah, the Golemized apps have all the same benefits that modularized apps do in general, in that the Golem modules, you can just reuse them. So the cover page for one app has the same, pretty much the same module as the cover page for a different app. And yeah, the Golem provides a range of tools and best practices for testing and debugging too. So I know there's other options available for generating modularized apps, but we found Golem to be particularly useful. We did find that it had quite a steep learning curve, and at the beginning I was feeling like it was just making things needlessly complicated until it took a while to realize the benefits. So yeah, it could seem like overkill for a really simple app, but I think it's always easier to do these things up front. So if you think that your simple app might become more complicated in the future, then it can pay to commit to working on using something like Golem up front rather than having to change everything in the middle. And the last challenge that we're still working on, I know there was a workshop on this yesterday, which I unfortunately missed, but yeah, we have implemented asynchronous programming using Future and Promises R packages in the risk engine already, but we really need to implement it in other apps too, and I guess it would have been much easier if we'd done that from the start. So for example, the Insights engine has a topic modeling option, and if somebody's running topic modeling on a big data set, then it means that nobody else can use the app for 10 minutes, which obviously is not ideal. So yeah, again, I guess the main what have we learned lessons are that planning things out from the start in terms of, even if options seem quite overkill when your app is still simple and you don't have many users yet, taking the time to invest in things like Golem, asynchronous programming from the start can save you quite a lot of time in the long run. So yeah, I think much more beneficial to just start doing that every time you're developing a new app. And I think I know I'm quite early. I went through that quite fast, but I think I'm at my last slide. So yeah, thank you for listening.